Hello everyone. 2023 is round the corner and it is the best time for us to look back and reflect how software engineering looked like 7 or 8 years back, and then you can compare with today and then you can plan ahead as well. So software engineering is a ever evolving game. The technologies and the things which were used 5 6 years back, they change, and people have to adapt to the new things. So the first thing first is that in 2015, the number of companies who used to think about the scale was very less. In fact, there was a saying that the scale or the system design rounds in the interviews were just a fad. You don't use them in the real world. But the things have changed a lot. The number of users on internet and the number of users who use any platform, especially in B2C world, they have grown a lot. So you have to plan your system way ahead. If you are having a food delivery app or a rider or cab service, anything, any simple service, you would need to think and plan how to go about scale. You cannot have a simple front end, back end, and the database based design. You need to think of scaling all the layers from day one. And in fact, in 2015, I recall that the system design rounds bearing a few companies were just like a checkbox that they used to have a round of design, and it was mostly a role play where neither the interviewee nor the interviewer has ever designed a very high scalable system. There were exceptions, there were few places where it was done, but many places I have seen that people asking just for the sake of it. But today it is getting more and more important. And if you see the technologies being used in 2015, so they were HTTP 1.1, WebSockets, and today people are moving more towards HTTP 2, and this is HTTP 3. And people are also moving towards gRPC because they have realized that gRPC can save the cogs. In fact, gRPC came in around 2015, and WebRTC is getting popular for video calling. So newer technologies are coming which are more optimized. People are moving towards that. So there will always be a catch up game where you would need to learn technologies which would have become popular in 2017, 18, 19. For example, Kubernetes and Docker as well. They gained traction around 2017 and 18, and I think a lot of companies, almost all companies, would be using some form of containerization. So that's the last point, that the life of DevOps was very hard. Back in 2015, I did some of the DevOps work as well, and trust me, the life as a DevOps engineer was extremely hard. The Docker and the containerization were not as popular, so we had to actually manually make sure that all the softwares are installed correctly on the machine. So you take a VM, you install all the software, you install all the certificates, and then you test it, and then you add it to the prod pool. And it is very much error prone. You could miss one or the other thing while deploying things to prod. So it was a hard time, to be honest, where people can make mistake and that can break down the system. In fact, the auto scaling system was also gaining traction, so we used to have fixed number of machines on the prod pool, and whenever we felt that more number of machines are needed, so we used to get more machines, install the software, and iterate the same process. So it was so expensive to have a different QA dev, pre-release environment, that we always had that problem of making the code testable and making the changes in the machine. So yes, software engineering is a function of time, and software engineering keeps on evolving every year. So if you have learned anything in 2017 and 18 and you think that you are done, no, you are not. The new things actually keep on coming up, and as a software engineer, it's important to play those catch up games so that you are also there with the right set of tools and you can use the right tool in the right place. And the second thing which I wanted to cover is around the software engineering being the function of years of experience. So this is also very much important for all the software engineers, because I also had illusion in my mind a few years back that I have learned everything. Whenever I go to interview, people ask me questions and I am able to answer those questions. So I am probably aware of all the computer science concepts. But that is not true. The software engineering itself is a big ocean. It's impossible for anyone to learn everything. It's literally impossible. And it's just that you evolve over years of experience. So I had that illusion that, hey, I know those concepts of sharding, publisher, subscriber. I know which database to choose. I know the common patterns which are being used while designing a system. So that should be okay. But if you zoom into each of those layers, then the new layer of challenge comes up. So if you ask a question, the same question, if you ask from SD1, SD2, and SD3, the expectation would be different. Sure, they would be able to answer the question, and these bifurcations are symbolic, they can mix and match as well. But if you ask a question from software engineer, let's say SD1, you would be probably okay for a food delivery app to have a front end, back end, and database. That person will be fresh out of college, and that person will say, hey, I'll have a front end, I'll have a back end, and I'll have a database, and the data will flow from front end to back end to DB, and likewise in the reverse direction. Now if you ask question from someone who is a bit experienced, that person will be able to add a sprinkling of sharding. That person will say, okay, I have a database, I will divide my database into one database for Bangalore, one database for Delhi, etc., and then I will have a better food delivery app. They will also add a bit of pub sub model, that these are the async operation, I'll add a pub sub model, and he or she will add a bit of database schema as well. So that's how the SD2 would think, and life is good for them. But the moment you get more senior, further layers down the line, you need to zoom into each of the layers as well. So it's important to consider the choice of tech. It's important to think about the, if you are saying PubSub model, so which PubSub model would be good? If you say that I'll use a NoSQL database, then there should be a proper rationale based on the limitations of the database and the pricing of the database, etc. Or if you are saying that, hey, Cassandra is good, let's use Cassandra, so you should know what are the limitations and the cost involved with Cassandra, because this happened to me as well. If you look into any of the documentation of any of the softwares or technology, there will be a marketing pitch in the first page of any website, and that pitch will say that this is the best solution out there. If you look for the solution of Cassandra, they will say it's best. Of course, they will have limitations later down the line. The same goes for Mongo, same goes for other databases as well. So it's more important to know about limitations, and with the help of that limitation, you can decide what to use. So don't use distributed system just because you have to use it or you want to use it. You should know the real reason, the cost of maintenance of multiple servers, and the number of people you need to deploy to make things work. So the moment, as and when you get more senior, you need to know more about the individual components and how those components will be chosen for the design and where you can fit in various systems. So once you know and understand the zoomed in systems, then joining them with the block diagram is very easy. So yeah, that was my learning, and in fact I would urge or suggest you in 2023 to learn software engineering by practice. Don't take things as a face value. You go online, you read or see things on YouTube, how to build a certain system. Don't take things as a face value. I would say that clone the repo or download the software, run it on your machine, and see how it behaves. Once you run it, personally, that's what I feel, that if I run a software, I get more confidence. Sure, if you have already run, let's say, Kafka PubSub model. So it might not be very useful for you to run Redis PubSub. It's a fairly, you know, it's the same thing. But you should be able to run the softwares and at least visualize how would that software behave. So you can practice each category of software or each category of the tooling stuff. So if there is a containerization stuff, Docker is a good candidate which you can learn. So once you learn Docker, you can understand other containerization methods as well. So yes, if you learn engineering by practice, that will be very helpful. So that's all from my side for this particular video. From the next time, I will keep on posting more videos on software engineering by practice. Till the next time, bye.